For our example here, what we want to do is compute the determinant of the matrix 3, 1, 2, negative 2, 0, 4, 1, 1, 5. Where with this, our first and most important decision is figuring out what we want to expand our minors around. We've got a lot of options here about what we can work with, but to my eyes, there's one candidate that's much better than the rest. Generally, you want to pick the row or column that has the most zeros, and if you don't have a most zeros, then you want to think about most ones. And here, if we look at column 2, that 1, 0, 1 means that one of our minors is going to cancel for reasons we'll see later, and the other two are going to have a simpler cofactor to work around. So that's our best bet here. If you can ever get 2 zeros, then you're in great shape. And if you ever get 3, well, your system doesn't deserve to be in terms of a 3 by 3 matrix, but take that victory where you can get it, because it's going to be really easy to compute the determinant at the very least. But anyway, we're going to expand around that second column. So when we're talking about generating our minors, looking at the 1 in position 1, 2, eliminating the row and column there will leave us with a determinant of form negative 2, 4, 1, 5. Then for the 0 in slot 2, 2, we will have a determinant 3, 2, 1, 5. And finally, for the 3, 2 position 1, sounds kind of cool. Anyway, for that, we will have the determinant 3, 2, negative 2, 4. So we want to take that determinant over there and actually compute it. What we're going to do is just expand out by those minors and their cofactors. We'll have 1 times negative 1 to the 1 plus 2, because it was in slot 1, 2, multiplied by the determinant that goes with it, plus 0 times negative 1 to the 2 plus 2, because it's in the 2, 2 position, times its according minor, plus 1 times negative 1 to the 3 plus 2 times the minor 3, 2, negative 2, 4. And here, it's just a lot of arithmetic, where the reason why we choose 0, or try and find as many zeros as possible, should be clarified by what happens to that second term. As we're going to be multiplying by 0 in there, that's going to condense out of the picture, and really what we have to worry about is that negative 2 times 5 minus 1 times 4, minus 3 times 4 minus negative 2 times 2. It's, again, kind of ugly, like with matrix manipulation, matrix multiplication. My words are pretty bad today, I don't know why. But it's similar to matrix multiplication in that the hardest part, once you get the patterns in mind, once you figure out what those basic determinations you want to do for your determinants are, is just chasing some negative signs around. It's even worse here because there are those negative 1s raised to powers, but it's the same sort of idea, same sort of difficulty. In any case, multiply that stuff out, and you'll get negative 2 for the determinant.